Hey everyone, Nitesh this side. Hope you are doing good. So let's start with the question. So the question is populating next right pointer in each node 2. Okay. So what is given to you? You are given a binary tree and this is a node of a tree. So it is containing a value. It's taking the left pointer, it's have right, and it's also have a next pointer. Okay. So what we have to do is we have to populate each next pointer to points to its next right node. Okay. So if there is no next right node, then the next pointer should be set to false. Okay, and initially all the next pointers are set to null. So what is given to you? You are given a binary tree, and in this left and right pointers are set. You need to set its basically right pointer. Okay, so let's see with an example. Okay, so we have this binary tree. So this is our root node. Okay, and in every node it's having a value, and it's have left, it's have right, and it's also have next pointer. Okay, so what we have to do at every point, we need to initialize the next pointer. Okay, so how we will do it? Basically we will do pre-order of our tree. Okay, so at every level we will initialize it. Okay, so what we will do, we will start from here and we will check. Okay, how we will check? We will check whether it is containing any element. So as you can see, this next is not containing anything, so we'll mark this as null. Okay, now like in the normal pre-order, how we are setting it, we will go to left part, then we'll go to right part, but in case of this we will go from right. Okay, so we will start from here, we will go to its right and we will check. How we will check it? We will first initialize its left. So as you can see, it is not containing any left element, so it's null. We don't have to do anything. We check for its right. You can see right is there, but right is there. So what you will do, you will check for its next element. So it will be like for this is having null. Then you will come at here. You will again check its left and right. Okay, they both are null, so you just return. And you also check its right part, and it's also having null. Okay. Next pointer is always on the level wise. So this. Okay. Now we'll come back. We'll come back. We'll go here. Okay. So basically we will check like this. Okay. So if our root dot left is not null, then do something. Okay. If our root dot right is not equal to null, then do something. So what we need to do when our left, now you come here, you see your left is not null. So basically you will check for whether if root dot right, basically root right element, if it is not null, then mark my left, basically root dot left dot right to root dot right. Okay, so then mark this to my next point. Okay, now there will be one more case. Let's say your tree is like this. So this is having 1, this is 2, and this is similarly 4. Now how can I decide? Yeah, so there will be 5 also, and now there will be 3, there will be 7, and it will be covered only in, so okay, skip this, we will cover this in at this point only. Okay, now we will mark it. Okay, and we will now go further, so we will go to its right part first. So we will check whether with 2 is it left part we have initialized. We will check for its right. Okay, so how we will check it? So we will just do root dot right is equal to find next. Okay, how we will check it? So it will be like find next to root. Basically what it means, you can see your right is not null and you don't have an element at this point. Okay, so 1 second, let's say if there is element 6, so you can map it again, but here it is not an element, so we have to map this with this. How we will map it? we will do like this. We will say our parent, do you have next? Okay, he said like I have the next, so we'll go to your next and we'll check if the next have left. Okay, you can see your next is null, so we'll not do anything, and we'll go to its right. Okay, so we will check whether its right is present. Yes, it is present. So what we will do, we will mark this to this. Okay, and let's say if this both are not there, 3 is also having one, you can say 8 pointer, and it is having 9 and 10, so then 5 will point to this. Okay, now there will be one more case also. So let's say your tree is like this, 1 2 3 and 4, and this is having 7. Okay, you mark this like this. Now you need to mark this 4. Okay, how you will mark it? Because it is having null here. So if you do like your left is not null and you check whether right is not null, so we can't mark this 4 to null because we have an option from 4 to 7. So how can we check? We say our parent. Okay, we'll call our parent and we check whether do you have next. He say I have. So we'll go here and we'll check from here. Okay, so whoever, like if left is present here, but right now it's also null, we will not give it. Its right is present, so yeah, that is present, so we'll return this node and we'll mark this like this. So this condition will be like else, like if right is null, what you have to do, your root dot left dot right, we will call a new function, we'll call a find next. The find next will pass the parent, and find next is just a simple it will be like a root node, and we will check whether the element have left, so return the left. If the element have right, return the left. If both having not element, then check its next. Okay, it will be more clear if we write the code for this. Okay, so we'll do a pre-order, simple. So what we need to check, if our root dot left is not null, we'll do something. If our root dot right is not null, we'll do something. Otherwise we'll do the normal pre-order, we'll call the left and we'll call the right. But in case of this question, we will call right because we need to set the right pointer first, then it will automatically, like it will be easier to set from left to right, because right is all automatic, like already visited, and it's already next is also initialized. So that's why we will initialize like we'll call the right first. So connect, we'll call the recursion and we'll pass right, and then we'll call the left, connect root dot left. Finally we just return the root. Okay, and we need to add base case. So if our root equal to null, we just return null. Okay, now let's handle this. So let's see. So first condition, if need to check if our right is present. So if our right is present, we just need to mark our left next. So root dot left dot next equal to root dot right. It's pretty simple. Okay, let's say your right is not present, then ask from your parent. So root dot left dot next, so it will be like the parent will find the next node. I don't have to find it, so find next, so give node. Okay, similarly for right case, for right is also like you can't say, like you don't know whether it is having a next element to it or not, because from left you have a right children, but from a right you have a different node. That is not like you can't mark this 3 2 something. Okay, so you need like for this case 5, you don't know whether 7 is present or not, you will say it directly to your parent. But for left we have a right children that we know, so that's why we have added a condition. Otherwise we'll only have this condition if we don't know from left. So right is pretty simple, the same else condition, root dot right dot next, that you will give me node, find next, and I will call my parent. So I think we have covered the main code. Let's write the find next. So node find next, and we'll give them node. Okay, so it will be like while node dot next is not null, call your next, so node dot next, and check if node dot left is not null. So at the time only, don't need to go further, just return your left children. Okay, if left is not present, check for right and return your right. If both are not present, you will call the next pointer. And finally, if there is no left or right to the corresponding children, so you just return the null. Okay, yeah, I think we have covered all the cases. Let's run it. Oh, why it is sign out? Let me just to sign in. Okay, so yeah, let's run it. So this is accepted. Let's submit it. Last submission 2020. Oh, okay, cool. So our time complexity is like we are just doing a normal pre-order of a tree. So you can say like how many nodes, if let's say n nodes are there, so we are visiting all the nodes, so it's a order of n. And space, we are using a stack space. So that's the space complexity. Hope you like it. Thank you for watching the video, and do join the Telegram group if you're in doubt and concern. Thank you.